Another aspect of dealing with formulas is potentially needing to solve a formula for one of its variables. So remember, a formula is just an equation that has two or more variables. Those variables have some kind of real world application and they're related to each other. Okay. So there are times where solving the formula for one of the variables is going to be powerful. So a couple of times in this semester, you'll definitely see something like this. It's just another way of practicing something we know too. So we're going to take these two ideas of dealing with a formula and solving equations, and we're going to merge them. Now, students tend to not like this as much because things don't simplify quite the way we do. So like when we're solving equations, things simplify very nicely. You're going to eventually get down to a single variable equals a single number. That's not going to happen here. When we're solving a formula for one of its variables, we're going to have that variable equals everything else. So things just don't simplify down quite as nicely as they do with just regular equations, okay? There is a note here, so it says solving a formula for a variable means rewriting the formula in such a way that the variable is isolated on one side of the equation. This does not mean finding a numerical value for that variable. It means we're relating this variable to everything else, okay? So for example 3, it says solve each formula for the indicated variable. So we're starting with a formula that most of you are probably familiar with. This is the perimeter of a rectangle formula. So we have P equals 2L plus 2W. So perimeter equals twice the length plus twice the width. It then says to go ahead and solve this for L. Okay. So what that means is we're still going to have a P, we're still going to have a W, we're still potentially going to have some numbers in here. It's just instead of being P equals, it's going to be L equals. Okay. So again, it's not going to simplify as nicely as we get with just regular equations, but it's the same exact steps. Okay, so the first thing I need to do in order to solve for L, I need to isolate the term that contains the L. So the issue here is this 2W. Remember, when we solve equations, we're just undoing what has happened to a variable. In this case, the variable that we want to undo everything for is the L. Okay, since it says solve for L, we want to get the L alone. So my first order of business is to get rid of that 2W. Okay, so I want to subtract 2W. Since 2W has been added to 2L, the way we undo addition is by subtraction. So I'm going to subtract 2W from both sides. This is another situation. It's fairly rare for me to leave stuff on the right, but I'll move that L to the left at the end, I promise. So for now, I'm going to subtract 2W from both sides. Now on the left, I get P minus 2W. That doesn't simplify, and that's the part that annoys math students. You're used to things simplifying down. But P minus 2W is just P minus 2W, okay? And then on the right-hand side, the two W's cancel. Now remember, I've said this many, many times. Things don't just disappear when we say cancel. We get very lazy as mathematicians and we say things cancel. That just means something has disappeared because it equals 1 or it equals 0. In this case, 2W minus 2W is 0, and then 2L plus 0 is just 2L. So we're getting closer. We have the 2L equals P minus 2W, but in order to solve for L, I want a single positive L equaling everything else. So what has been done to the L now is it's been multiplied by 2. I need to undo that multiplication. And there are two ways to do this, so I'll show you both. You can divide both sides by 2. We know that we undo multiplication by division. Looking at the L, our goal is to get a single positive L. Well, if I divide 2L by 2, 2 divided by 2 is 1. We get really lazy and we say, oh, the 2's cancel, and that leaves me with a single positive L. And then on the left, I just have P minus 2W divided by 2. So I would rewrite that as L equals P minus 2W divided by 2. That is one perfectly acceptable way to write this. Sometimes you will simplify this further, okay? So let's get back to that point where we're like right here. We had 2L equals P minus 2W. I'm just showing you another way that you could have simplified this, okay? Instead of dividing both sides by the 2 that's multiplied by the L, we could instead multiply all of the terms. So instead of just dividing the two sides, I'm going to divide all 3 terms by 2. It's the same thing. You're not going to like lose any kind of equality here. So 2 divided by 2 on the L, well, 2 divided by 2 is 1, so we say the 2's cancel, so that leaves me with just L. P divided by 2 is just P divided by 2. That's not going to simplify. And then if I look at the W, negative 2 divided by 2 is just negative 1, so I get negative 1 times W. These two things right here are the same. I would accept both, okay? So just be cautious. Both of them are the same, like I said. Some books, some online homework might prefer one to the other. Just know for me, I'm okay with either. Okay? Let's look at part B. Part B is something that you will definitely see when you get to the next chapter. When we start talking about graphing equations in two variables, you'll see stuff like this, where you've got x's and y's and constants, and it is very, very common to be asked to solve for one of the two variables. You typically solve for y. There's a good reason. You'll learn about it much, much later in this class. But for now, we're told to take x over 3 minus 4y equals 5 and solve it for x. That means we want to get the x by itself equal to everything else. Okay. Now, the first thing I see is this 3. I don't like the 3. I want to get rid of the 3. Okay. That 3 in the denominator is going to force me to deal with fractions. I would rather not. So what I'm going to do is I'm going to start by multiplying all of my terms by 3. Remember, we can clear fractions by multiplying all terms by the LCD. So I'm going to take all of my terms and I'm going to multiply them by 3. And all that's going to do for me is it's going to get rid of that fraction. I just don't want to deal with a fraction. Well, 3 times x over 3, the 3's cancel. Remember, we say cancel a lot. It's lazy. 3 in the denominator divides into 3, the LCD, one time, leaving me just 1 times x. That's what's really happening. Negative 3 times 4y is negative 12y. And then 3 times 5 is 15. So what's really cool about that is I now have a single positive x. I just need to get rid of this minus 12y. Okay, so we want to get the x by itself. The minus 12y is an issue. We undo subtraction with addition. So I'm going to add 12y. 12y minus 12y, or negative 12y plus 12y on the left. That just cancels to become 0. Negative 12y plus 12y is 0. X minus 0 is just x. So there's our single positive x. And then that's going to equal 15 plus 12y. I would also accept 12y plus 15. I don't care which version you give me. Generally speaking, you would see it more like this, where you put the variable term first and then the constant last. I'm okay with either of these versions. Just make sure you get a single positive x equaling everything else in the formula. Okay. And again, something like part B, you will definitely see situations similar to that when we get into graphing linear equations in two variables.